All right. Good morning, everyone. Welcome. So today we'll talk about an introduction. I call it AI for all. So let's talk about the biggest news in the last 2 years about AI. So first, we'll talk about Nobel Prize in 2024. So the Nobel Prize for physics, it was actually awarded not for physicists, it's actually for computer scientists for their work in artificial neural network. Nobel Prize for chemistry, it was awarded not for chemists, it's actually for computer scientists for 2024. For the Nobel Prize for physics, it's about their work in artificial neural network development and innovation. For the chemistry, it was solving the protein folding problem, which wasn't solved for more than 50 years, and they use AI to solve the protein folding problem. Next, the biggest thing in the news is big AI company like the AWS, Google, IBM, they are building their own nuclear reactors to power AI system because the current traditional electricity are not enough, and they're not going to wait for the government and private sector. So guess what? They're building their own nuclear reactors. That's how serious the AI development system and the need for power and electricity to move AI and research. Next one is, I'm sure you know this, you see it on a daily basis, AI generating content that indistinguishable from reality. For example, this young lady, she does not exist. She is completely created by AI. As you can see, the resolution, and it's unbelievable. That's how it's indistinguishable from reality. And this old lady here, it's a video actually, and I'm not sure if we can run the video, but actually the same thing. This is a video from OpenAI about grandma influencer. She's trying to make, recipe, and that's the video, but apparently the video is not working. So the credit for this picture is from thispersondoesnotexist.com, and the video is from OpenAI. Now, this is a summarization about the whole presentation. So first we'll talk about AI, then we'll go deep inside. We'll talk about a branch of AI or a subset of AI called machine learning. Then we go inside machine learning and we talk about a branch or a subset called deep learning. Then we go inside deep learning and talk about the generative AI. So this actually summarizes the whole presentation. So what is AI? AI simply is simulating and imitating the human intelligence. And we'll talk about more detail. So AI is not a specific hardware or a software or a method. It's an umbrella, just a word, an umbrella, that's cover everything and anything that imitate or simulate human intelligence. So if you hear the word AI, it's really not a specific thing. It's not a hardware, it's not a software, it's not a methodology, it's just anything, any topic, it's called AI. Now we'll talk about the types of AI. So mainly we have 3 types of AI. The first AI, we call it narrow AI, or A and I, which is almost in everyone's pocket right now. So what is an AI and I? It's a very specific AI to do a specific task. For example, we have Siri, we have Alexa, we have Cortana for different operating system or phones. That's what we have right now. So that's why narrow AI is available right now. Now, what's the next one? What's the next type of AI? The next one is called general AI, or artificial general intelligence, which knows everything about any task. So it's equal human intelligence, not in a specific domain, in anything. That's called generative AI, artificial or AGI. It's expected to happen in 2040. So if you heard about artificial general AI, that's what they're talking about. They're talking about this AI that can knows everything about any topic, not in a specific domain. Now, let's talk about the third one. And if you heard about AI and existential threat, they're talking about number 3, which is super AI, or what they call it, artificial superintelligence, which there is a concern about gaining consciousness. But it's not yet here, so you can relax until 2050. So you don't need to worry about it right now. It's happening 2050, so we can chill and have good time until 2050. Until 2050, actually, no one knows. When AI gains consciousness, we have no clue. Some scientists think we will be second citizen. We don't know. But that's, if you read about literature about existential threat, they're talking about type 3. Now, let's talk about AI techniques. So there is multiple AI techniques. The most famous one, almost all of us in AI community you hear about, is machine learning, or ML. We'll talk about machine learning more next slide. Then we have NLP, natural language processing, which focus on language, mainly human language, but also non-human, actually computer language. But mainly it started the research in natural language for human. The next one is automation and robotics. They're more hardware or algorithm related to robotics, whether about sensing and understanding different type of signals. So these are more specifically for robotics and automation. Then we have machine vision. Just to let you know, these areas, they're not completely isolated. They actually, sometimes they merge with each other. They're just putting them in a different category to focus on research, but actually sometimes they merge with each other, especially NLP with machine learning. We'll talk about that in more details in the next slides. So what is a machine learning? Okay, we know an AI is just an umbrella. It's a keyword, doesn't really mean anything. It just covers anything related to human intelligence that we are trying to imitate. So then what is machine learning? Machine learning is a subset of AI that focus about learning from data. Okay, so what's learning and what's data? We'll talk about it in the next slides. So if you use a calculator before, you wrote a program. So let's say you're trying to add 1 + 2 = 3. Your input data is 1 and 2, and the output is 3, and the operation uses a plus. So this is the traditional programming for the last 50, 80 years. What we are doing, we are getting input data, and we write a code, a program, and then we get the output. So if you compare it with the calculator, 1 and 2 is the input. The code we write, the program, you're defining a relationship between the input to reach the output, and that used to be written by human, the program, to get the output. So what is machine learning then? Machine learning, as you can see here, we actually take the input and the output, and machine learning write the program, find the relationship between the input and output, and write the program. The program output from a machine learning, we call it a model. Okay, so after the slide, I use the word model. I'm not going to use program, but a model is a relationship discovered by AI between the input and output. Now you might say, okay, that's good. It just only applies to the input and output specifically, right? No. It's actually, you can generalize. So once you understand the relationship between this input and output, you can make a generic about any input and output. Let's say here, let's call this model f as a mathematical model function. You can take that function with new data that you haven't used in training the model to get an output. And that's simply, this is a summarization, which is a machine learning. So simply, we learn from data to find the relationship. Once we learn the relationship, the model, now you can apply it to new data. So that's what's machine learning. Now, the machine learning has a life cycle. There are steps to build the machine learning, so I'll go through this quickly. So the first step is collect your data, get your data, then clean the data. There is maybe duplication, missing data, whatsoever, so you clean your data. Then you start the training process. We'll talk about training process in the next slide. Sometimes when you train your model, you get training error when the expected result doesn't match the model output. We call it training error. And when you do the testing, remember at the beginning when we have our data, we divide it to two categories, data for training and data for testing. And the data we use while training the model, and if there is an error, we call them training error. And the error from testing the model, we call them testing errors. Why and how helpful these testing, error, and training? We'll see them in the next slide, why they are important. Then we can improve our model to reduce the errors, testing error. Now, if you have a model, let's say that red line is trying to differentiate between the circle and the stars. If the model, which is the red line, the mathematical here, ignore the data, just go through them, we call that underfitting. If you heard about underfitting, that's what an underfitting. The model really doesn't capture, doesn't understand the difference. The extreme to underfitting is overfitting. The model is literally understand the training data, but doesn't work with testing data. What we are looking for, actually, we don't want underfitting and we don't want overfitting. We just want something in the middle, which is optimum. Now, let's talk about machine learning types. There is two main types. There is more than two, but we're just focusing on the mainstream ones. There is two types of machine learning. We have supervised and unsupervised. So in supervised one, like the previous slide, we feed both the input and the output. The input, the x1, x2, and 3, and the output y. Unsupervised, we actually just put the input, give the input with no output, and leave it to algorithm to actually distinguish between this input to discover something between them and put them in different categories. So we have here as a type of supervised, we have regression and classification. Regression to to predict a specific number. Classification to put them in classification to categories, whether it's a binary classification or multi-classification. And clustering, we put them in different category without the need of output, and that's what we call it clustering. Now let's talk about the deep learning. So what is deep learning? Deep learning is actually, it's machine learning. The only difference is we are using neural network. What's neural network? That's what we're going to talk about. So let's talk about the human brain a little bit. So in the human brain, from a computer science perspective, and a neuron has three only components. We don't care about other components, okay? We only have inputs, places, we call it the dendrites, and we have a CPU, a processing unit, nucleus, and we have an output axon, and that's it. We don't need to do anything else about biology. Now, we have an equivalent mathematical modeling for the neuron in the brain in the human. We call it artificial neuron. So simply, these are the input. We call them simply input. And there is two mathematical functions inside. One is called linear, and the other one is an activation. The difference in the detail is beyond the scope. But anyway, there is math function inside that do the processing. Then we get the output. That's it, as simple as that. This neuron called artificial neural network, which is actually the heart of everything about deep learning. So in human brain, how the learning happen? Learning happen when there is two neurons make a strong connection between other. When there is a strong connection, you learn something. You adapt a new skill or knowledge or emotion or a feeling or whatever. When you actually make that connection weak, you do unlearning. You forget, you remove. And we simulate the same thing in artificial neuron mathematically. So we have two artificial neurons. We increase the depth mathematically, and instead of 0, put any value between 0 and 1 to make it stronger or weaker. So for comparison, the human brain has about 100 billion neurons and about 100 trillion synapses. And ChatGPT-4, for comparison, we have 2 million neurons and 1 trillion synapses. We don't use the word neuron in ChatGPT. We just, analogy. We just use an example. Now, what is an artificial neural network? So artificial neural network, from the previous slide, every circle is an artificial neuron. And as you can see here, we have 3 layers. By the way, a layer is vertical, not horizontal. When it's artificial neural network, a layer is vertical. So how many layers we have? We have 3. We have the red one layer. It's called the input. The second one is the middle one that does the processing, and the last one is the output. Now, the strength of a neural network is actually measured by the hidden layer, the one in the middle. The one layer you have, more intelligent you have, because it can capture more complexity and dimensionality in the data. So this one is considered simple neural network. If you increase the depth, this is what is called deep neural network. So deep because there is more processing layers inside. And in ChatGPT 4, there is 100 hidden layer inside, just for comparison. Now, how to build, you can arrange this neuron in different architecture to achieve different purposes, okay? So as you can see, every architecture there, when you're going to use it underneath each different architecture. So GPT is a short for a generative pre-trained transformer. It's an architecture by mixing this architecture and the primitive one to build the transformer. So this is, if ChatGPT is a car, you know, the car has an engine. So if ChatGPT is a car, the engine is GPT, and this is what a GPT. It's an architectural neural network designed to do that job using these different architecture elements. Now let's move to generative AI. So what is generative AI? We covered AI, machine learning, deep learning. So what is generative AI? Generative AI is actually deep learning. Well, what's the difference then? The difference is create new content that does not exist. Wait, I thought you used data to teach them. Yeah, but the content coming not from copying and pasting, it's coming from learning. It's like a human brain. When you learn something, when you learn about how to write and read, you're not literally writing what you learned before. You're actually learn how to write. And that you create something new as a human. And that's how AI actually works when it comes to generative AI. They learn from the data how to read, how to write. So let's talk about example about generative AI. So generative AI, the engine behind generative AI, or the output of generative AI, is called large language model. We'll talk about large language model as an example for generative AI. So what is a large language model? Or if you heard the word LLM, it's very famous, the phrase LLM in AI community. What is an LLM? So first, LLM is a deep neural network. That's the first thing. The deep neural network specialized in languages. So as you can see in the input in the left side, we feed this deep neural network multiple data, you know, web, books, traffic, whatever. Then we can tune the output to adjust a specific task, like answering, questioning, sentiment analyzing, information, summarization. The output of this deep neural network after training, we call it pre-trained model or foundation model. So, by the way, we measure the complexity of a model by counting these links. You see these links in black color? These links between the neurons, we call them collectively parameter. So that's how we measure the complexity of a deep neural network. So as you can see here, NLM size, GPT-1 has about 100 million parameters, so it's considered small. Why? Because if it's more than 100 billion, we consider it big. And as you can see here, GPT-4 has 1 trillion parameter. Now, can you build a large language model at home? No, don't try it at home. Why? Because it costs 100 million to build one. So as you can see here, ChatGPT-4, the last red colors, it costs 100 million, and it consumes about, these are rough estimation of the amount of electricity to train a model. It costs about 25,000 home electricity of 1 year consumed a month, every month, to train for 3 months or 6 months. Massive amount. Do you remember the first slide when the AI company, they're building their nuclear reactor? That's the reason. They're not going to wait. There is not enough electricity. And it's a bottleneck. We'll talk about other slide why energy right now is the bottleneck of AI research. Now, how to enhance large language model accuracy? I'm sure you heard about hallucination, all that stuff. So how to enhance the accuracy? There is multiple ways. You can build it from scratch. Whenever there is new data, you take this new data and you train it from scratch. But guess what? It costs 100 million and 6 months. So that's not practical. Only like 5 people or 10 people can do this in the world, which is Google, AWS, whatever. So no one is doing this, training from scratch. This is the most reasonable one, which is actually fine-tuning. So in fine-tuning, you download an open source, pre-trained large language model that already knows the language and the detail and everything. Then you customize it to a specific domain. If you are in a medical research, you actually bring your medical literature or research or whatever, and you just add to that area. That's called fine-tuning. The next one is RAG. This is very common actually in research. I actually use this with my student to complete a project in 1 semester, which is called RAG. We'll talk about it in the next slide, retrieval augmented generation, how to improve it in a very, very simple budget. It's almost free, and you can do it in 3 months if you use one of the free HPC platform available. We'll talk about it in the next slide. And the last one is the one you do, all of you, when you use AI. What you do, use prompt engineering. You more details, you put context to improve the answer of an AI. So what is RAG? What is a retrieval augmented? So let's talk about the classical way when you communicate or contact an AI chatbot. So usually you just ask a question and the large language model, which is the engine underneath ChatGPT or any AI tool, then you give you a response. That's the traditional usage. But with RAG, when you ask a question, your question is interrupted, and it's taking aside, and it's find keyword in your question, then bring relevant document to your question, and submit both your question and this relevant document to the AI chatbot until the AI chatbot do not answer the question outside the document that attached with the question. And that's RAG. That's RAG. This is the same thing, you know, what's mean of RAG. So I want to focus on, because of the time limitation, I want to jump in and talk about HPC. How many minutes do we have?
We have 7 minutes
Ooh.
of the time, so with questions also. So
Ooh.
I want to leave a few.
Thank you for letting. I will go fast. So you might want to pay attention. Okay, so HPC. So what is an HPC? HPC is kind of a supercomputer that you can use to do AI research because AI need a lot of data, and your laptop or desktop really is not going to process and able to store and manipulate this data. So you really need a supercomputer. Well, a supercomputer is expensive, $1 million, and I don't have $1 million to buy a supercomputer. What shall I do? Well, you don't need to buy one. You have 3 ways to access supercomputer for free in the US. You have a program called Access. It's NSF program to access multiple supercomputer for free. And you have NAIR project, and you have NRB. My friend Frank will talk from UC San Diego. He will talk about NRB in next presentation for more details. So when you combine both HPC and AI, you can really do real science and exploration. All right. So this is the summary of the whole presentation. We talk about AI, machine learning, deep learning, and generative AI, and large language model. Now, if you are new to AI and you say, okay, I'm interested, I want to work, but there's a lot of things going on. I don't know what to do, where to start. Well, start with 3 things. Start with ChatGPT, become your new friend. ChatGPT right now, latest version, equal having a PhD in all human knowledge. Just try to use it extensively. Eventually, you will get to know how to use it in a very efficient way. So number 1, you need to have a ChatGPT or an equivalent AI tool. Next, Google Notebook LM. If you don't know what Google Notebook LM and you're doing research in a hard way. Really, you're doing it old school. I can't talk about it because it's a time limitation, but I will just give you a simple example. If doing a survey paper or literature review, usually takes 6 months to 3 months, it depends how many references you have. With Notebook LLM, it will take you days. All right. The next one is Google Colab. What's a Google Colab? It's almost visual Python language programming, and PyTorch is an open source library for deep neural network architecture. And I build 14 courses for free in GitHub to teach you anything about AI and supercomputer with zero background. Actually, they're written for high school students, and that's why they have emojis and cartoons and everything. This is to teach high school students how to do supercomputer and AI using 14 courses in GitHub for free. Now, I will talk about this topic quickly. How many minutes we have?
Gosh, we have just 4 to the very end, so I need to go to...
Okay, so I will just do this and I'll skip. Now, this is more for faculty. More faculty, they're very concerned about AI. Students are using AI to solve everything. We can't teach anymore. What shall we do? This is the guide for you. 90% of students are using AI to solve, courses material, and really they're not learning anything. So what is the idea? I built a guideline for faculty called AFCL, AI First Critique Learning. The gist of it, because we don't have time, the gist of it is to make your assignment AI ready. What's in AI ready? AI ready is an assignment that AI tool cannot solve. Why? Because of 3 things. First, you give the student a prompt about something you discussed in the class, so ChatGPT was not sitting in the class listening to you, so AI tool has no clue. This is number 1. Number 2, you give the student lenses. Give me the pros and cons of social or economic and discuss these lenses. You might say, well, the AI can do that. Yeah, but you discussed something in the class, and again, ChatGPT was not sitting there. Number 3, and the last one, oh, well, students will copy from each other. No, you're asking for the trail. Every single screenshot of their usage of AI tool, they have to collect it in one single PDF and show it to you in screenshot with the timestamp. That's the gist of it, because I don't have time to cover it. And this is a graph, how this guideline works. This is more for faculty, how you can tell your student, go ahead, use any AI tool to solve this problem. I am open. Actually, that's what I do in my class. I tell my student, use any AI tool in the world. I'm okay with it. Say, wow, he's very flexible. And that's the end of my presentation. Thank you, everyone.